In this video, we are going to continue our discussion of the dot product and show how it can be used to calculate work. Okay, so recall from a physical science class or physics, if you've had physics yet, that work is done. Let's define work. Work is the energy transferred to or from an object via application of force along a displacement. So that's how much energy is transferred from an object through an application of force to create something to move. Okay, so the work W done by a constant force F in moving an object a distance. So this is the formula you maybe have seen before. Work is force times distance. This rule, though, and this is probably the only thing you've seen in your physical science class, maybe. This rule is valid only if the force acts in the direction of motion. So that picture to the right there, the force is pushing the block in the same direction, the distance that we're talking about. Okay, but that's not typically the case when we're talking about forces moving. We have that, but forces don't have to be applied directly. So assume the force is a vector instead. So look at our picture down on the left there. The force is pulling up, almost like pulling a wagon maybe, or something like that. We're moving that block across distance d. In this case, work can be done by force. By the force is the component of the force in the direction of motion, multiplied by the distance moved by the object. So we could do some trig here and come up with this formula if we really wanted to. I'm not going to take you guys through that trig formula, but if we work it out and we get down to this. Now, if I use the formula from earlier, in this section talking about cosine of theta, and I replace it and we look at the alternative form, we actually can find that work is force dotted with distance. That's just from this formula from above. The formula gets me there. So that's a nice little definition. If I have the force vector and I have the distance, then I could just dot them and find the work. All right, take an example here. A constant force F, 241, in newtons moves an object from 0, 0, 0 to 2, 4, 6. Distance is measured in meters. Okay, so I have a force vector, and they want us to find the work. Force vector is 2, 4, 1. The distance vector is, we have those points, so we got 2, 4, 6. So just subtract them. Luckily, we started at 0, 0. And then if I want to find the work involved, I just dot the 2. All right, so if I dot those two, I have 4 plus 16 plus 6. Work is 26. All right. Okay, there we go. I think the distance, they said meters, so a Newton meter, is that a thing? My units typically for this stuff is a little weak, so we'll leave it at 26 as work. I think it's a Newton meter, but my physics isn't where it should be fully, so we'll leave it at 26 for work.